Okay, so yeah, welcome to my talk today. My name's Tim Fox. I'm going to be talking about, well, you can see it on the screen, high-performance reactive applications with Vertex. I'll just say a few introductory words about myself. I'm currently employed by Red Hat. I'm paid to work on the Vertex project, which is pretty cool, just paid to do that full-time. For the past 9 years of my career, I've worked exclusively in open source, nothing but open source, which is also good. Some other projects I've been involved with, other than Vertex, I worked with the RabbitMQ team for a while in Spring Source, only, well, kind of a year or so. I'm the creator of the Hornet Queue messaging system, which is the one at the inside JBoss application server, also known as Wildfly these days, and a few other projects. Anyway. So today we're going to talk about Vertex. This talk's actually, it's kind of an overview talk, but I'm also going to do some demos as well, so it's not kind of completely boring. But I'll kind of basically describe, what's the motivation for Vertex, why we're doing that, and just go through some of the main features. So can I just have, just so I have an idea, how many people here have already used Vertex? Okay, so a few people, right? How many people have used Node.js? So a few more, okay. So one way, if people ask me, what is Vertex? How do I describe it? One way is, sometimes, well, we're kind of almost known, this is what we're kind of known for, really. A lot of people say we're kind of Node.js for the JVM. But we're not really, it's kind of more than that. We have a superficial similarity to Node.js, but we're definitely not a clone. And when I was starting out with Vertex, when I was working at VMware, and I started to form the ideas for Vertex. Certainly Node.js was one source of inspiration, but I kind of thought, well, I don't like everything about Node.js. Some things are a bit crap, and I'm sure we can do it better. And we can do it on a better virtual machine, what I believe to be a better virtual machine, the JVM. Another source of inspiration is Erlang. How many people have used Erlang here? Oh, okay. So Erlang, very interesting platform. Again, I worked on that as part of the RabbitMQ project. So obviously, that's Erlang, written in Erlang. Erlang is one of the things that is an implementation of the actor model. So it's definitely inspiration from there too. Vertex itself is not an actor implementation, but there are certain similarities, okay, especially in terms of concurrency and that kind of stuff. Another kind of unique factor of Vertex is we are very much polyglot. By polyglot, I mean we support a lot of different JVM languages, and I think we support more than just about any other project in this area. And yeah, this slide's actually slightly out of date because we're not actually in the latest Tech Empower and benchmarks, because there was basically in the latest round of the Tech Empower benchmarks, they tested against a very old version of Vertex. We withdrew the results. I think you did the same as well. Yeah. But anyway, we're very high performance. You can look at independent benchmarks and judge for yourself, but we're right up there toward, actually at the top compared to most frameworks. And another source of inspiration for Vertex was we want it to be really simple, but not simplistic. So we want to get away from this kind of, the bad old days of, the traditional Java platforms, Java EE style complexity. I know I'm kind of being a bit unfair on Java EE there, because it has actually improved a lot in recent years. But even so, we're kind of, we want to get away from the whole kind of like app server way of doing things, and that's kind of a kind of big motivation for Vertex. Okay, so yeah, I mentioned polyglot. So right now we support, we support all these languages: Java, JavaScript. We actually have we support three different JavaScript engines. We support the old Rhino engine. We support the new Nazorn engine that's from Oracle, and we support the Dyn.js engine, which is one worked on by some people in Red Hat. Ruby, obviously, Groovy, Python, Clojure, Scala. Scala and Clojure are kind of a bit embryonic. We're still working on them. The API is going to be improved and stuff. So it's kind of very much the more beta level support. And we actually even support PHP, which is, I'm not a huge fan of PHP myself, but you can use it with Vertex if you want. And Ceylon, which is another language from JBoss, Red Hat. Okay, so I'll show you some actual code in a minute. So, but first of all, I just want to talk about, at the core of Vertex, we have this kind of a very small set of APIs, and they're all asynchronous, right? And if you've used Node.js before, it's a similar kind of idea. They're quite low-level APIs. They do stuff like TCP, HTTP. We have a full WebSockets implementation. We have sock.js support built in. Sock.js is... Who's heard of sock.js? A few people. Who's heard of Socket.io? A few more people, yeah. So Socket.io, similar kind of idea-ish. But basically, the idea is you... and it's actually becoming a bit less relevant now that browsers are kind of, getting more up to date. But the idea of sock.js is it gives you like a WebSocket-like API in your browser, even if your browser is like old, it doesn't support WebSockets, or maybe you're running behind a corporate proxy or something like this, doesn't allow WebSocket connections. And it basically falls back to one of many transports, so it detects that WebSockets aren't available, and it's all transparent to you. What else? File system support. We have asynchronous file system support. We have an event bus. I'll talk a lot more detail about the event bus a bit later on. The event bus is probably, I think, the most important feature of Vertex. It's the nervous system of Vertex. And we have kind of DNS and UDP support. So basically the idea is you have these very small set of APIs. They're all quite low level, and that's the core of Vertex. And that doesn't really change much over time. And I'll get into that later, but most of the functionality of Vertex is not actually in the core, it's in modules that are mainly contributed by the community. But anyway, so back to asynchronous for a bit. So why asynchronous? Why do we, because arguably asynchronous, callback-based APIs are arguably harder to reason about, harder to, harder to test, debug, all this kind of stuff. Well, that's not entirely true in all cases, but there is a good point there. So we don't want to force you to use that approach. Unless there's a good reason for doing it. And there are also ways of mitigating against that, using kind of Rx, Java, something like that kind of stuff. We'll get to that as well. So why an asynchronous approach? And it's all about concurrency. It's all about your system being able to handle a high degree of concurrency. And now not all applications need to handle a lot of concurrency, and in which case you can probably get away with not using such an approach. But certainly today and going ahead, then we're finding people. Internet of Things is a good example. Internet of Things, things like MQTT and other protocols which have long-lived connections, or even a web server, or even WebSockets connections. All these kind of types of applications, you may have many, many, many connections. And that's one source of concurrency, of one area where you get a lot of concurrency. So if you're using a kind of, if you're blocking threads in your application, and those threads can't do any work, well, they're blocked, and you've got a problem, scalability problem. And even though threads these days on most good operating systems are a lot more lightweight than they used to be, there is still overhead there in terms of, a lot of overhead in terms of, the stacks, the RAM for the stack, plus the context switching overhead. Okay, so the idea is if you take a non-blocking approach, you can basically scale much better, and you can support a lot of concurrency only using a small number of operating system threads. So that's why we take that approach. And so a non-blocking, one further little step, a non-blocking approach to I/O then feeds through to the asynchronous APIs. Okay. Actually, continuations is a possibility, but continuations don't work well on the JVM, so we don't get that route either. Okay. So how do you actually write a Vertex application? So any Vertex application is composed of these things called verticals, and a vertical is basically the execution unit of Vertex, the kind of chunk of code that you actually execute, right? And any particular vertical can be written in any of the languages that Vertex supports. So you could have a JavaScript vertical, Groovy one, a Java one, whatever. So you have your application composed of these things called verticals, and each one is single-threaded. There is actually an exception to that, but I won't go into that now. But you can assume for now they're all single-threaded, generally are. So instantly you've got a win there. You can write all your code as single-threaded. You don't have to worry about synchronized and volatile, and lots of race conditions just don't happen. A lot of deadlock conditions that you're probably used to if you've battled with Java-style multi-threaded concurrency. Well, that's a bit unfair calling it Java-style because it was actually around before Java. It's C++ style as well, I guess. But so you're probably thinking at this point, I'm sure most of you are familiar with the actor model, right? So you think it sounds a bit like the actor model. You've got these things called verticals that sound kind of a bit like actors, and they're talking to each other by passing messages. Did I mention that? Okay, so they talk to each other by passing messages. So it does sound like a bit like the actor model, and there is, we are similar in our approach to concurrency. We are similar to the actor model. We're not strictly actor model though, and that's a good thing because the actor model is a good thing, right? Okay, so let's have a look at a vertical. So in Vertex, you can basically you can write things called what we call raw verticals, and raw verticals are very good for kind of demos and prototyping kind of stuff, right? And a raw vertical can be run directly on the command line. So I have a directory here, and I've got a couple of raw verticals. One's called Helloworld Js, written in JavaScript. So let's take a quick look at that. Js. Okay, is it displaying all right? Just about. It's a bit. Let me just change my resolution there. My where is it? Edit profiles. Make the font size a bit smaller so it fits on. Is that better? Yeah, that's better. Right, okay, so here we have a very simple JavaScript example. And if you've used Node.js before, you'll be familiar with this kind of thing, right? Very trivial example. It's basically creating an HTTP server, setting a request handler on that server, and that request handler is just a function, and that function will be called when a request arrives, at which point we're just going to say, send back a bit of static HTML saying hello from JavaScript. Pretty trivial example. So how do you run that? You run it. The easiest way to run it, just a vertex run, then the name of the vertical, the file. Okay. Let's go to our browser. Localhost 8080. There we go. So it's running. Okay, simple example. So let's go back to that directory. We'll shut that one down. I've got another file in there called helloworld.java, and this is the same thing written in Java. In Java 8, actually, so we can use lambdas. Okay, and actually, Java 8 is a really, really good thing for developing against asynchronous APIs, because Java 7 is horrible. Anything before Java 8 was horrible because there's no lambda. So you have to write kind of anonymous class, and it's just nasty, basically. So this is actually a really big win for Java 8, and I think they've been pretty smart in putting lambdas in there. So again, it's doing the same thing as a JavaScript example, creating an HTTP server, setting a request handler, and just sending back a bit of Java, a bit of HTML, sorry, saying hello world from Java. So how do we run this? So, well, it's a Java source file, so you're probably thinking, well, we have to compile it first. Maybe you have to write a build script so you can compile it to a class file and then run it. But actually with Vertex, for prototyping, you can actually run the Java files directly, and it will actually compile it on the fly for you. So you can just say vertex run hello world Java. Okay, and then we go back to the browser, F5. Okay, so it's kind of a nice feature. I mean, in a real application, you'd probably pre-compile your Java classes, but it's kind of nice for doing demos anyway. Okay. So let's move on to the event bus. I mentioned before the event bus is a really important feature of Vertex, and it's kind of one of the main areas it sets it apart from, say, Node.js, right? So this is where our kind of similarities we take it one step further, and we're not, it's not just a Node.js clone. So the event bus is the nervous system of Vertex, and it's the means by which verticals communicate. So they communicate by sending messages over this event bus, and the event bus is really just it's a transient messaging system, a lightweight peer-to-peer messaging system. And we support, the classic messaging patterns, point-to-point messaging, publish-subscribe messaging, request-response. And, you can pass we're pretty much agnostic about what you pass on the event bus. We don't say this is this complex messaging model and you have to do it in this way. But you can just pass strings, primitive types, byte arrays, buffers, stuff like that. It's up to you. One thing we kind of recommend for many applications is to use JSON. It's not a golden rule. We don't mandate it, but it's a kind of recommendation. The reason is, if you can imagine, you might have people using different languages with Vertex. And one thing that's very well understood by all the different languages, very easy to parse, very easy to create, is JSON, right? So in every language, it's just easy to deal with. Can you imagine if you had some sort of complex Java serialization format and you were sending it to a Ruby vertical, and then what would it do with it? It'd be hard to work out what to do with it. So we recommend JSON, but it's not a golden rule. Yeah, so the event bus lives inside a single JVM instance and allows the verticals in that instance to communicate with each other. But we also extend it so it can actually work between different JVM instances on the network. So it's actually a kind of distributed messaging system. Like I said before, a lightweight peer-to-peer messaging system. So this is kind of the vision for your application. We're going more towards a sort of microservices model. Yeah, so going away from a kind of application server model. So in an application server model, you kind of have this big application server which sits somewhere on your network, and you deploy applications into it, right? We don't do that with Vertex. Instead, you create your application. There's no application server. You create your applications as these chunks of code called verticals, and you can just basically run them wherever you want on your network. So maybe in a more complex application, you have different teams in charge of different parts of your application. Maybe the different parts are written in different languages. Maybe you have a kind of web team, want to use JavaScript. Maybe you have like back-end processing team, they want to use statically typed language like Scala or Java. That's fine. There's no monolithic application server. So you basically have your application as a set of loosely coupled components that can live wherever you want. And then we can take it a step further too. So we can actually push the event bus into client-side JavaScript too. And so not only do you have your components on the server side talking to each other across the event bus, you can actually have talking to client-side JavaScript too. So you can have servers talking to stuff in browsers, browsers talking to servers, browsers talking to other browsers, servers talking to other servers. It's all a completely flat kind of address space. Yep. And actually, on the client side, in client-side JavaScript, the event bus API that you use is the same, well, more or less the same as the event bus API you would use in server-side JavaScript too. And we don't preach about what other tools you should use on the client side. So you can use Vertex on the client side with whatever you're already using. So maybe if you're doing like real-time web applications, maybe you're using like Ember, Knockout, Angular JS, something like that. That's fine. You can just carry on using that. Yeah. So I will actually let me show you another demo actually of the event bus. Make it a little bit clearer. Right, so I've got a directory here, and there's again some more raw verticals in there, and one of them is called Receiver.js, and obviously written in JavaScript. Let's have a look at that. This is again a very simple example. This time it's doing a bit of stuff on the event bus, so it's basically just doing the subscribe part of publish subscribe messaging. It's subscribing to an address, which just happens to be the string newsfeed. It could be anything. And it's setting a handler against that address, which basically just means whenever any message arrives on that address, it's gonna get that message, and it's going to log that out to the console. So kind of trivial example, right? So let's run that. And the way we run it, we say, again, Vertex run receiver.js. Now this time, I'm going to add a switch cluster on the command line. And what this does, this tells Vertex, when you're running, I want you to also now look out for any other Vertex nodes that might appear on the network. And if they do appear, then form a cluster with them to form this kind of big event, distributed event space. Yep. So a receiver by itself is not much fun, so we need a sender too. So let's do that. So let's take a look at a Scala example. I should say at this point the Scala API is actually still in flux. This is not necessarily a final API, it's still developing, and Galda, who's been doing the API, is bringing out a new version soon. So let's take a quick look at the Scala Sender here. And it's a very, very simple example. What we're doing here, set periodic, that sets a timer. That timer is going to fire every second, every 1,000 milliseconds. And when it fires, we're just going to publish a string, news from Scala, to that same address that we are listening on in the other process. Yeah. Right, again, Vertex run sender.scala to run it. So you can run both Scala source files and Scala compiled classes in Vertex, similar to Java. Again, I'm going to add the cluster switch. So now we have two different JVMs running. They could be running anywhere on the network. They don't, just obviously on this particular demo, they're on my laptop, but they could be running anywhere on the network, these two different things. We go back to the other one. The receiver has obviously picked that up now, so it's picked up that and it's working. So you can see that is working. So that's kind of simple event bus example. Now let's make it a bit more interesting by, let's push that out to client-side JavaScript too. So what we're going to do, so if we're going to push it to client-side JavaScript, we need to serve a page, an HTML page, right? So there's a page already prepared here. Let's take a look at that, index.html. My demos are a bit boring, I'm afraid, but I don't have any kind of kittens and cats with hats and stuff. But very simple example, index.html. Basically, it's got a lump of JavaScript in it. And all it's doing is it's opening a connection to the event bus. And when that connection opens, it's going to register a handler against that same address. So it's actually using the same API, EB register handler, against the same address, like exactly what we did on the server side. And when some data arrives, in this case, we're just going to write it to the page using a bit of jQuery. But you can do whatever you want with it. Okay. So if we're going to serve a page, we need a web server. So there's a web server that I already wrote, again, using Vertex. So let's take a look at that. Very, very simple. There's an obvious security issue with this web server. Leave that as an exercise. It's pretty obvious. But anyway, so I wouldn't recommend you actually run that in production. But it's a very simple example of a web server, the kind of thing you can do. We're creating an HTTP server. Like we did before, we're setting a request handler on it. The request handler will be called when a request arrives, at which point we're just going to say, is the request for the root? If so, we're going to serve index.html. Otherwise, we're going to serve whatever's on the path. Okay, pretty obvious. Now, the little bit towards the bottom of the screen, well, above the listen, the create sock.js server, that's the kind of bit of magic. I won't go into the detail of how that works now, I haven't got time. But that's basically does the magic of actually bridging the event bus over to the client-side JavaScript. Okay. Right, so let's run that web server. Vertex run bridge server.js. Again, we're going to use the cluster switch. So at this point, we have three different JVM processes running. We have this web server. We have that sender.scala on the server side, and we have the receiver.js on the server side too, all different processes. Let's go to our browser, F5. And then you can see the browser's picked that up now. So the browser thinks it's in the same address space as if it was on the server, basically. So this is actually a kind of, it's kind of a nice feature of Vertex. So, and what we find is a lot of people are using this for this, so-called, the modern term of real-time web applications. It's not real-time in the sense of the computer science definition of hardened software real time. It's more kind of webby definition of real time, which basically means kind of pushing stuff to browsers. So we find a lot of people are using Vertex for stuff like multiplayer games and that kind of stuff. Is quite a good example of where this kind of stuff is very useful. Okay. How am I doing for time? Check my clock. All right. So one feature I want to talk about now is the module system. I should say a lot of this is going to change. We're currently working on Vertex 3.0, which is the next big generation of Vertex, and that hopefully will be out by the end of the year. And there's going to be quite a lot of changes. One of the themes of Vertex 3 is we're going to really simplify a lot of things, and we're actually going to simplify the module system. So what I'm talking about now is what the current state of Vertex is, but some of this will change. But yeah, Vertex has a module system. And that we have a module system for the same reason anybody has a module system, which is to encapsulate your code, the resources of your application into like a manageable chunk that you can kind of deploy and move around nice and easily. Up to now, you saw what we call raw verticals. So raw verticals, like I said, are very good for prototyping, but if you had like 100 different verticals, you wouldn't want to be kind of manually copying them around and trying to work out the class path each time and all that kind of stuff. It would get pretty ugly. So that's why we have modules. So a module, you know, you typically, in a real application, you typically have one or more modules, and those modules can contain many different verticals. And they just make it easier to kind of manage your application. The simplest module of all just contains a single vertical. Well, actually, you can have a non-runnable module. I won't go into that now, which has 0 verticals in it. But anyway, I digress. But each module has a what we call a mod.json descriptor file, which is basically just tells Vertex a bunch of things about the module, like how to run it. And in the simplest case, it just has a single field called main. And it basically tells Vertex, when you run this module, what you actually have to do is execute this vertical inside it. It basically stipulates the entry point to the module. Yeah, so modules also provide class loader isolation. So you can actually have, running in the same JVM at the same time, you can actually have multiple modules. And let's say you have one module using one version of a jar library, and another module using a different version of the same jar library, the same package names, class names, then they can be isolated, basically. Like I say, some of this is going to change in Vertex 3, so but it's kind of some people find it a nice feature. Other people actually don't particularly like the class loader isolation. So let me show you a module that kind of make it a bit clearer. So let's shut down these other examples from before. Okay. I have a directory that I prepared before. I'm going to copy it over to a directory called mods. So now we have a directory called mods. Now mods is it's an important directory in the Vertex module system. Mods is the default place where Vertex will look for modules when you try and run a module. Vertex will also look in other places, but that's the first place it looks, the local directory called mods. And this will be familiar to you if you're from the Node.js world. They have a similar idea. You typically have local module directories. So in this case, we have a directory called mods that contains another directory with a funny name, io.vertex hello mod 10. And actually, it's not such a funny name. It's not such an unusual name. I'm sure most of you have used Maven before. Probably all of you have used Maven before, right? It's basically like a Maven coordinate. So a Vertex module is named in a unique way, in pretty much the same way as you have a Maven artifact, right? So you have the group ID, the owner, which is the first part, io.vertex. Then you have the name, like the artifact ID, hello mod, and then you have the version. And there's a very good reason for doing it that way, because it allows us to then put modules inside any Maven repository, because we can uniquely reference it. Okay, so let's take a look inside that actual directory. What have we actually got in there? So inside this module, the very, very simple module only has a single vertical inside it. And this time this vertical is written in Groovy, just for a bit of variety, and it's called helloworld.groovy. And we have another file called mod.json, which is the descriptor file I mentioned earlier. So let's take a quick look at the descriptor file. Just a bit of JSON. And, very simple example. It's just saying main hello world groovy. That basically says, if you try and run this module, then Vertex will actually look up what the main is, and that's what it will actually execute to begin the module, right? Pretty obvious. Let's take a look at the actual vertical inside there. And it's just the same example from before, the Hello World web server example. This time written in Groovy. I'm just going to say Hello World from Groovy, right? Okay, so how do we actually run a module? So before, we ran Vertex raw verticals by saying Vertex run. And the way you run modules is actually very similar. You say, instead of saying Vertex run, you say Vertex run mod, then the name of the module. So this module is called IO Vertex Hello Mod 10. Okay. Okay, it's done something. Let's go back to our browser. F5. Okay. So what happened there, when we ran the module, the first place it looked for the module with that name is in the local mods directory. It did find it, and so it just executed it from there. Okay. So let's delete that mods directory, rm-rf fr mods. It's gone. Let's try and run that module again. Let's say exactly the same command line. Oh. I don't have an internet connection. Oh, my Wi-Fi's not working. Right, so that's why it didn't work. Let me just check my... that's why. Anyone know the password? Sorry? I should have checked this before. Thank you, Roland. Very kind. Right, let's try that again. Hopefully it'll work now. Yay. Okay. Let's go back to our browser. It's still running. So what actually happened there, so the second time I ran it, it looked for that local mods directory, but this time it wasn't there. So it said, okay, at that point it looks in other places, and one of the places it looks is in Maven Central. And it just so happens I put that module in Maven Central some time back. So it found it in Maven Central, downloaded it, put it on the disk, and ran it from there. So actually, if you look now on the disk, you can see that that directory's reappeared. It's reinstalled it. Yeah. So Vertex will actually, it can resolve dependencies at runtime as well as build time. Again, this might be changing in Vertex 3, so I won't say a huge amount about that. But the important point is you can put your modules. We're not trying to reinvent the wheel. We're not trying to impose a new repository format. We're saying, look, most of you probably already use like Maven repositories or maybe bin tray repositories, a new repository. We support both of those. So maybe you already have like a Nexus repository inside your organization. You can carry on using that. So you can use that to put your modules in there. We're not trying to impose a new repository format on you. Okay. Yeah, so that's where we're going with the module system. So we're trying to get to a situation. We want the community to contribute Vertex modules. Like I said before, the actual Vertex itself is quite low level. The core of Vertex is pretty low level. And typically, if you're writing a Vertex application, you may well be reusing a lot of modules that other people have written, doing like database stuff or whatever. So we want to encourage this kind of ecosystem of modules so that when people want to write an application, they can say, OK, I want to write, say, a real-time web application. What do I need? Maybe you need like a database module here. You need like some other module. So you basically have a selection of modules, and you can like glue them together like Lego bricks to create your application. So and right now we have this is just a few examples of modules that we already have. And actually, most of the modules were written by the community, not by the core team, which is good. We have a pretty vibrant community. The amount of modules is increasing all the time. But we have some examples are we have a load of NoSQL stuff like MongoDB and Redis. We have kind of SQL stuff, MySQL, Postgres, JDBC, various other bits and pieces. An MQTT module, a new one recently. We have MQTT. I'm sure most of you have heard of that. It's kind of Internet of Things. So actually, I think Vertex, Internet of Things is going to be quite a good target area for Vertex. Because right now, a lot of people doing Internet of Things stuff are using Node.js. So it's kind of like an ideal, if you don't want to use Node.js, maybe you're a JVM developer, maybe you don't want to develop just in JavaScript, then Vertex is a really good choice. Other examples, Rx Java. This is an interesting one. Who's heard of Rx Java? Okay, so quite a few. So Rx Java, if you're not aware of it, so Rx comes from Microsoft originally, Reactive extensions. And it's a way of, like I said before, when you're dealing with a lot of asynchronous streams of data, it can become quite hard to reason about it if you don't have a set of tools to help you compose them in kind of intuitive ways. So that's where things like Rx come in. So they allow you to take these streams of data and then use kind of like functional style operations on them to combine them in interesting ways, and it makes it much easier to reason about it. RxJava is basically kind of, whereas the original was done by Microsoft, they basically Netflix did RxJava and they put it onto the JVM. And there's actually versions of RxJava for other JVM languages too, like Groovy and Scala as well. So we have an RxJava module, and actually in Vertex 3, which we're working on now, we're going to improve that support as well. So when you're writing your Vertex application, you won't have to deal with the raw callback style APIs. You'll be able to like use an Rx API, or maybe you want to use, say, a Java 8 completable feature. We'll also support that way of doing it. Okay. Oh, I'll say one more thing about module system. One of the things you can do with the Vertex module system is you can convert any module into what we call a fat jar. And this is kind of like a popular technique at the moment, fat jar, so-called fat jars. And basically all it means is you have an executable Java jar, and that Java jar also contains the actual Vertex binaries itself, right? So you have a single unit. You can then copy that to any machine. As long as it has a JDK on it, then it will just run in exactly the same way. And the overhead's actually pretty small, because Vertex itself does not have a lot of dependencies. And the Vertex jars itself are very small. I mean, I think it's like just over 1 megabyte or something. Yeah. Overall, the overhead is about 4.7 megabyte, and most of that's because of our dependencies. So we have we use Netty, and we use Hazelcast by default if you're using clustering, and we use Jackson for our JSON support. So all that combined comes to about 4.7 megabytes. So it's still pretty small. Okay? Actually, let me show you an example of a fat jar. Okay, so yeah, so the previous example, we ran that module. So instead of saying Vertex run mod, I'm just going to say Vertex Fat Jar. And what this does, it tells Vertex, convert this module into a fat jar. And now, if we look in that directory, you can see there's a jar. Right? And this is an executable jar. And you can just run it, saying Java. You can copy it wherever you want. Don't have to have Vertex installed. Java minus jar. Oh, so I actually forgot to include the Groovy stuff inside. That's why it's downloading it on the fly. Because with Vertex, in the core distribution, we don't include all the language runtimes, because that would make it really big. Yeah, if we include like JRuby and Rhino and everything, it'd become really big. So what we actually do is we lazily install it the first time you come across a language. Yeah. So for many people, they'll only use like maybe 1 or 2 languages. So we don't want to impose the overhead of having all these other language runtimes on there. Okay, so we go back to our browser, F5. You can see it's still working. Helloworld from Groovy, right? So it's the exactly the same module, but this time in a fat jar form. And actually, if you look at the size of it, oh, it's actually 6 meg now. Okay, yeah, right. So some of the dependencies have changed size, but so 4.7 meg is slightly out of date, but it's 6 meg. It's still not particularly big. Okay. Alrighty, so the final thing I want to talk about is HA. This is also probably going to change a bit in Vertex 3, but Vertex has high availability support built into it. And what do I mean by that? What is high availability? The high availability is the same meaning as that you already know. It's basically the ability for your application to continue to function after failure of one or more parts of your application. So what you can do with Vertex, you can deploy different Vertex instances on your server side, and if one or more of those fail, then other ones will detect that and they'll redeploy the modules running on them. Those nodes can be logically grouped into subgroups too, so you can have a particular application only perhaps failing over amongst a subgroup of those nodes. And we support, network partition detection, split brain, using a quorum approach, a very standard approach in distributed computing. Like most things, probably the best way to understand it is to see a demo. So let's take a look. Right, so I have another directory I prepared earlier, so I'm going to just delete the old mods directory here. I'm going to copy across this other directory here. So now I have another mods directory, this time with 2 modules inside it. One's called Groovy Sender, and one's called Python Sender. And these are just the same example we saw before. let's take a quick look. So let's go into the Groovy one. On directory, Vertex, Groovy Sender. Again, a very simple module. We have a single vertical inside there. This time, this one's written in Groovy, called sender.groovy, and it's the same event bus example from before. It's just publishing every second. It's going to publish news from Groovy to that same address we saw before, right? Let's take a look at the other directory, the other module, the one written in Python. Again, a single vertical, this time written in Python. And we're just doing the same thing. We're just every second, timer's going to fire, it's going to publish news from Python to that same news feed. Okay. Right. So yeah, 2 modules. We can run both those modules now. So let's run the Groovy one, Vertex run mod, IO Vertex Groovy Sender 10. Now this time we're going to run it with high availability enabled. And the way you do that, you just put HA on the command line. Let's go to another console. And let's run the Python one as well. So we have 2 modules running in different JVMs. Vertex run, Vertex run mod. And if I can type. Okay, again, minus HA. So at this point we have, you can see in this particular situation we said the quorum size is 1, which is kind of just for a demo. So it's actually detected it's got that many nodes in the net on the quorum, so it's going to deploy it. So now we have these 2 modules running, just sending stuff. We don't have any receiver. So let's push that out to the client-side JavaScript again like we did before. So let's get our bridge server, and let's run that same web server that we ran before that served that HTML page, yeah? So Vertex run bridge server minus cluster. So at this point we have 3 different JVM processes running, one running the Python module, one running the Groovy module, and one running the web server. Let's go to our browser. 5. And you can see the browser's picking up those 2 different senders on the server side. Okay, so it's all working as expected. So what we can do now is let's kill one of those JVM processes on the server side. Let's kill the one running the Groovy sender. So let's find out the process ID of the Groovy sender. And let's kill that. Kill -9, 4, 107. Yep. Now, if you go, yeah, you can see that's been killed, right? And you can see the other node has basically detected that the other one died, and it's taken over responsibility for that module, and it's redeployed the Groovy module. So now we have a single JVM running both the Python module and the Groovy module. If we go back to our browser, you can see, I'll just F5 again. They're both still running, okay? So it's failed over. Right, so what we can also do, let's start up a empty Vertex node. It not actually running anything, just an empty JVM Vertex process. And the way you do that, you say Vertex minus HA. So we're not running any modules on this one. So we've got 3 processes, one running the web server, one running nothing, and one running both the Python and the Groovy sender. Okay. Let's now kill the module that's running both the Python and the Groovy one. So let's find out the process ID of that, and that was originally called Python sender, so it should be that. Kill -9. Oh, where's he gone? Up there. Yeah, so that's died, right? And you can see the other one, the empty one, has now detected that, and it's redeployed those 2 other modules, right? So if we go back to our browser, they're both still running, right? So that's HA. So you can see it's very simple. There's no kind of complex configuration. You just put -HA in the command line. I mean, you can specify like quorum size and stuff as well. I didn't show you that there, but there are a few other parameters that you can tweak as well. Okay, how are we doing for time? Okay, 10 minutes. So the other thing I just want to briefly touch upon is the whole kind of developer experience. And again, we're kind of going to do a lot more work on this with Vertex 3.0, which is going to be a really very interesting release. But even with Vertex 2, you know, we've put quite a lot of work into getting it to play nicely with your IDE and your build system. So Vertex itself is, we don't say you have to use this build system. We don't say you have to use, you know, this IDE. We're completely agnostic. You can just use a text editor if you want. However, we realize that most developers, probably especially in the JVM world, tend to use IDEs. So we kind of play nicely with, you know, IntelliJ and Eclipse and all that, and NetBeans. And also we play nicely with Maven and Gradle in particular. Or you could just use Ant if you want. It's up to you. We have a Maven archetype. So if you like Maven, you want to create a Maven-style Vertex project, then you can use the Vertex Maven archetype to create a skeleton project. And we have a Gradle template project you can clone from GitHub if you're a Gradle user. So we kind of, you know, work nicely with all those kind of things. We have a nice feature called module auto-redeploy. And I don't have, sometimes I give a demo of this, but I haven't really got time today. But basically what it is when you're developing your module with Vertex, say inside your IDE, and you can have your module running in the background, and as you change stuff, it can detect the changes and it automatically redeploys it. So you can kind of like, say you're doing a web application, you can change something and immediately just go to your browser and you can see it's updating without you having to kind of force a rebuild or anything like that. So it's kind of a nice feature. Yeah, that's the demo I sometimes do there. Okay, yeah, so that's pretty much it. Let me summarize where we're going with this. So, you know, the kind of Vertex vision is kind of moving away from this kind of application server model and moving to this idea. You can write your application as a set of loosely coupled components. Maybe perhaps written in different languages. It's completely up to you. Maybe you have different teams, you want to work on different languages. Maybe you want to use the right tool for the right job. You can do that with Vertex. So you have your application communicating by sending messages, you know, different parts of your application potentially in different places. A very simple actor-style concurrency model, so you don't have to worry. You know, all the same good reasons as you would get with other with actor implementations. So basically, simple concurrency. You don't have to worry about synchronized and volatile and all that kind of stuff. Yeah, so you're scaling by having many instances of verticals. We have a module system, so you have a library of these kind of Lego bricks that you can use to build your application. Have HA support and easy development. So that's kind of where we're going. And I'll just finish about telling you a few little words about the kind of the governance of the project. So I work for Red Hat, but the project Vertex is not owned by Red Hat. It's actually the IP and the trademark and everything is owned by, well, it's governed by the Eclipse Foundation. So I started Vertex when I was at VMware, and then we basically transitioned it to a neutral foundation after I left VMware. So this is good because it means there's no one company which can, you know, dictate the direction. Okay. Yeah, it's all the code's on GitHub. I mean, like most projects really nowadays. We're using 100% open source, of course. We were the JAX Innovation Award winner for best Java technology recently, which is a very nice surprise. And we're currently one of the most popular Java projects on GitHub. I should say, I've kind of mentioned it a few times already. We're currently working on Vertex 3, so there's loads of new development happening. We think Vertex 3 is going to be an even better Vertex. Really exciting stuff we're doing there. So if you're interested in getting involved, then please do. We're kind of, in the next few weeks, we're going to probably open up development. At the moment, it's kind of like we're concentrating on just a couple of members of the core team, because we're doing a lot of refactoring in the core stuff. So we can't have too many people working on it at this stage, because we just tread on each other's feet and get loads of merge conflicts and stuff. But that's going to be complete soon, at which point we're going to open things up more to everyone else. And there's loads of new stuff to do. So if you're interested in contributing, there's loads of like new modules and stuff we want to get in there. So then please do. That'd be really cool. Yeah, we have a Google group. That's where most discussions occur. We have an IRC channel on freenode.net, so you can join us there if you like as well. And that's basically it. So thanks for listening. I hope that was helpful. I think we have some time for questions if anyone wants to ask any. A few minutes. So the question is, how do you write tests for verticals? Right, so like I've said this several times in this talk, actually, this is probably going to change in Vertex 3. But right now, we have our own kind of test framework, which allows you to basically deploy your test inside the Vertex environment, basically. So you basically have to, you follow a set of rules, basically, and you can write tests that way. In Vertex 3, we're going to really simplify things so you can actually write tests in much more simply.
Hello. Is there some sort of real-time console where you can see the messages and the nodes and the instances of vertices?
Yeah, good question as well. So right now, one of the things we're really missing from Vertex is the whole kind of monitoring statistics. And we targeted that as like a major area. Again, Vertex 3, we're going to be doing much more in that area. Yeah. So we're going to have we'll have a console, and we're probably going to maybe reuse some stuff there. But basically, the idea is we'll have a console and you'll be able to get statistics and all that. Yeah, on the Vertex 3 timescale towards the end of the year. We don't have any monitoring support built. No, currently we don't expose any metrics at all. No, but it has been noted as a area, and it's a known area we need to support. Any more questions? Oh, a question just down here.
If you got the HA module turned on, and how do you kill all those verticals running? Because they just seem to spawn like zombies.
How do we kill them?
Yeah, how do you undeploy one of the verticals? Because you got three
right.
different versions. You want one dead.
So how do so you're asking how do you like shut it down without killing it, without failover kicking in?
Without killing all the instances. I just want to undeploy. You had, for example, Groovy version and Python version.
Yep.
Python version is deprecated right now. For example, we want to undeploy it from all the HA nodes. And how would you do it without killing all the nodes?
Well, it's only deployed on. I mean, you deploy whatever you want on each node. So in that case, it was only on one node. So all you do is you basically. So we killed it by doing kill -9. So if you do a clean shutdown, if you do like a -3 signal, or Control C, then it won't cause failover. It will just shut down cleanly. So if you want to just take a node down, you can just send it that signal, basically.
Okay, thanks.
Okay, anyone else? Okay, I think that's it. Oh, no, there are a few hands over there. Sorry, can you repeat the question? How do you solve the codependencies between Java modules? So you're saying if two Java modules depend on the same, yes, that's where the class loader isolation comes in. So they're running in their own class loader. We have a hierarchical, in Vertex 2 anyway, we have a hierarchical class loader model. So it will actually, it'll load the classes in a different class loader. That's how you get the isolation, basically. Yeah, that is also changing in Vertex 3. We're going to have a much more simplified, flat class loader. Well, it's going to be optional, basically. So right now, the default is a hierarchical class loader model. In Vertex 3, we're actually going to have a flat class loader model by default, although we will support isolation if people want it, but it'll be an option. So it actually makes, because in many cases, people don't actually they don't care about the class loader isolation. And, maybe they like using Maven to resolve dependencies at build time, so they know they're not going to have any clashes. Okay, in which case it's just an overhead and people don't necessarily like it.
I've got a question concerning HA. Is the load balancing somehow how the modules are redeployed on different servers?
So how do we determine which node redeploys? So it'll basically just choose one randomly from the group.
Okay.
Yeah. So so if you want your application only redeployed to a subgroup, you can set up basically a subgroup. You can actually specify that, so you can have multiple subgroups in the cluster at any one time. Okay, thanks everyone.